Welcome to this video where we're going to have a look at how to grow a moon, or more specifically, how does a moon get in the location that it actually is. But before we do that, let's first define what a moon is. So a planet is a large object which orbits around a star, so the Earth orbits the Sun, but a moon will orbit a planet. So if you had an object, say, the same size as a moon, but it was orbiting around the star, then that would be a minor planet or an asteroid. So it only becomes a moon when it's in orbit around a planet, and that is the defining characteristic of a moon, which is important going forward. So the thing that classifies it really is its orbit, what it's kind of doing with its motion, as opposed to its actual size. And to give you an idea of that, really, we've got Ganymede and Titan, which are very large moons in our solar system. In fact, Ganymede is the largest one. Titan has a very significant atmosphere. And then below you've got Mercury and Pluto. Now, Pluto isn't technically a planet, it's a dwarf planet, but you can see that the two moons at the top are considerably larger than a planet. So Mercury is smaller than some of our moons. So it's not about the size, it's about their orbit. Now, not all of these moons are created equally. So on the left-hand side, we've got Jupiter and the Galilean moon. So you've got Io, Ganymede, Callisto, Europa. So 4 Galilean moons, they formed in one particular way. You then have our moon in the middle. That would have been formed from a different process compared to the Galilean moons. You've got Triton around Neptune. Again, different process as to what caused that to be where it is. And then Rhea from Saturn. All of these have a different process that place them on an orbit around their planet, and we're going to have a look at what those processes are. So the obvious one really is the Earth-Moon system. Most people are probably aware that the Earth and the Moon were formed from some significant collision early on in the timeline of the Earth, basically. So the early Earth would have had a collision with a smaller planet called Theia, and that would have been quite a significant impact that would have almost destroyed both objects, and there would have been significant mixing of the two, which is why we have similar compositions to the moon. That would have caused a large disk of debris all the way around the Earth. In time, that gravitational self-attraction would have come together. It would have made an object known as the moon. Some of it may have fell back down onto Earth, some would have fell onto the moon. We may have had smaller moons as well as the main moon orbiting, but over time we're mostly left with this one significant moon and the Earth. It also kind of would have tilted it a little bit during the impact. So that is one of the scenarios, as a collision scenario. This is the giant impact scenario, really, for the Earth and the moon. Now, Uranus went through a similar thing. So Uranus was impacted by a planet much larger than Theia, so about a few times the size of Earth, so a fairly significant impact here, but it was more of a glancing blow. This would have caused a similar disk of debris all the way around the planet. That in time has accounted for some of those moons that are orbiting Uranus. Now, the key thing with both of these collisions really is that the moon, the moons, and the rings that were all formed after the impact would have been orbiting in the same direction as the planet. So we'd call this prograde, so the moons orbit in the same direction that that planet rotates, which is quite important really. It's one of the key aspects to what we see with these moons compared to some other formation scenarios. The other one really is more specific to the Galilean moons, so Jupiter's main moons, is that they formed with the planets. So early on, whilst the star or the sun is still forming, you have a disk of gas and dust orbiting around it. The planets form in that disk, and then around those planets you have moons forming in that gaseous disk as well. So they kind of form together. So the planets and the moons form together before all of that disk is lost. So when the sun actually reaches the main sequence, it starts generating energy properly. All that gas will get blown away, and then you're left with the planets and the moons orbiting them. So they would have formed together. That's another scenario. So here you have the Galilean moons, the 4 main ones, and one of those is the largest in our solar system. So Ganymede is our largest one. So they're all quite large, but they formed with Jupiter. Now, looking at the actual Juno spacecraft image as it approached Jupiter, you can see Jupiter rotating in the center. And you can also see the Galilean moons orbiting around the outside. Now, if you pay attention, you can actually see that they are going in the same direction. So same as the collision theory, really, you should find that the moons will orbit in the same direction that the planet is rotating because they formed together. So as the disk was rotating around, they formed in that, which means that they actually retain that direction of orbit. Now, another one where it's not a full collision is a tidally destroyed moon. So with regards to Saturn's rings, they obviously have a very significant ring system compared to Jupiter, Neptune, and Uranus. Saturn's are, fairly significant. And one of the ideas for how they got there was a tidally destroyed moon. So an object the size of a moon really, it came too close to the planet and the gravitational tides basically pulled it apart. And then that caused this ring of debris around without actually having a physical collision. So there is something called the Roche limit, and that's a distance from the planet where it can be tidally pulled apart. If it's outside of that, then it's fine. If it goes inside, then the tides from that planet are so strong it will tear it apart. And that's what's happened here. So then you end up with a ring system being formed just like Saturn's. But from that ring system, the moons would typically form at the ring edge. So unlike a very large collision where you have a large debris disk spread out over a wider area and you'd have the moons forming, here moons are likely to form at the edge and then they drift out. So zoomed in on Saturn's rings here on the edge of the A ring is a new moon forming that was found a number of years ago, and it kind of sat at the edge of the rings. What would happen there is it would be expected to grow there and then it would leave the edge and migrate outwards, although this particular one wasn't seen again, so it could actually have ended up being destroyed. But they typically grow at the ring edge. And if you look at the architecture of the moon system around Saturn, the further away the moons are, the larger they are. So it's a rough approximation on their sizes here, comparison. Closer to Saturn's rings, they get smaller. Now, the reason for that is each time a moon forms at the edge and then moves away, the ring gets smaller. So there's less material in the ring to grow a moon. Now, those moons actually cause features in the rings. They get like these waves and things. They, in themselves, push on the moon and they move their orbit further out, so they migrate outwards, and then the next one forms, and so on. So you end up with this structure where they're ordered in their size if they form at the ring edge, a bit like Saturn's rings. Now, the more interesting one for me, really, is the captured moons. So here, you've got a planet orbiting a star. You then also have minor planets or asteroids orbiting the star as well. Now, if the two get close enough and their speeds are relatively low, then the minor planet, the smaller object, can get captured onto an orbit around the planet. It then becomes a new moon. Now, it didn't form with the planet. It formed somewhere else in the solar system, and then it just got captured onto a new orbit. It's now a moon. And Jupiter and Saturn have very large groups of these captured moons. How do we know that they're captured? Well, they have orbits that are not like the normal prograde one. So prograde is orbiting the same direction as the planet's rotation. So Galilean moons, good example. These are classified as like a retrograde group. So these orbit in the opposite direction, which has some serious consequences for some collisions, because if you have a prograde one, a bit like the green one here in the red group, you can get collisions between them. But it gives a very unusual orbit, and the only way they can get there is if they've been captured. So Jupiter has a large group of these captured minor objects that are now moons. Saturn also has the same. So again, this red group is a group of captured objects. These sit a bit further out in the prograde group. They go in the opposite way, and the only way they can really get there is if they've been captured by other smaller objects getting a little bit too close. Now, the biggest captured moon in the solar system is Triton. So Triton is a very large moon. It does have an atmosphere, and it's larger than Pluto. And it orbits in the opposite direction to the rotation of Neptune. so we know it's captured. We also know where it came from. So it's larger than Pluto, but it's of a similar composition. It came from a similar location. And this is our largest captured moon. And the interesting thing here is that this size object could potentially be a planet in its own right, depending on its orbit. So you've basically got a planet that has captured another planet, although it would have been classified as a dwarf planet given its location, which is in the same location as Pluto. But it's interesting to think about that a planet can capture a planet and have it as its moon, and then it would be known as a moon instead. So just a size comparison then between Pluto and Triton. So Triton is bigger than Pluto, yet it's actually a moon and been captured. It didn't form around Neptune, it was captured as it got too close, and it also has an atmosphere. So again, possibility depending on where it actually was, could have been a planet. So where do they actually come from? Well, they're thought to be captured Centaurs, or at least some of them are, some of these captured objects. So these are a group of objects that orbit in and around the gas giants. So between Jupiter and Neptune, these basically orbit in some kind of chaotic manner. They're not stable because the gas giants perturb them. They can't be on a stable orbit, but they can get close enough to be captured. So if one gets close enough to Jupiter, Saturn, Uranus, or Neptune, there's a possibility they can actually get captured as a new moon. But where do the Centaurs themselves come from? Well, we have a scatter disk in the Kuiper belt, which is beyond Neptune. This is a large collection of smaller objects. It's where Pluto is. So Pluto is basically one of the largest members of that group. And it's a huge reservoir of these sorts of objects that can get knocked in or perturbed in from other interactions from other planets, from external interactions, and they move inwards. They themselves can then get captured as a moon. But the more interesting thing really is that we have found two objects that have come through the solar system that have not originated here. So these are interstellar comets. These have origins outside of our solar system. They've come through and they've passed out. And this is interesting because we've actually seen them. So we know that we have objects coming into our solar system. But also there's some work or research that suggests that some of these outer objects, in the scatter disk Kuiper belt, maybe the Oort cloud, could be populated by interstellar objects. So if we basically put all that together, we've got objects that can get captured by planets that have originated from the outer part of the solar system. Yet it's plausible that you could have interstellar objects in the outer part of our solar system that are captured by the solar system itself. So you could put all that together, and there's a possibility that some of these irregular or captured moons may have interstellar origins, which raises some interesting questions going forward. And this is obviously very early on, and these objects have only been found very recently. We might find some more in the future. So, yeah, some of these objects around the outside of Neptune, around where Pluto is and further out, could they be captured as moons? And I'll leave that as an idea for you to really think about in the future. So thank you for watching, and if you enjoy, then you can check out some of the other videos.